Hello student, today we are going to discuss about the Neber rearrangement. So first we are going to discuss about its principle. So it is a base catalyzed rearrangement. It is base catalyzed. So here we are using base, right? So it is base catalyzed transformation. It is base catalyzed transformation of ketoxime tosylate. So here your starting material should be ketoxime tosylate and your final product is alpha amino ketone, right? Alpha amino ketone. So here ketoxime tosylate is converted to alpha amino ketone via azerine as a intermediate, right? So ketoxime tosylate is converted to alpha amino ketone. Okay, if we discuss the reaction part, so in reaction, for example, in reaction CH2 CH double bond and OH. This part is known as oxime. So how it is generated we will discuss in the mechanism part. So here oxime first react with the para-tolyl sulfonyl chloride. Para-tolyl sulfonyl chloride, which is also known as tosyl chloride. So first it is converted to OTS group. Here OTS. So here OTS act as a leaving group. After that it react with the base. For example NaO, it is sodium ethoxide, and the final product is CH2NH2. So कार्बोनिल कार्बन के पास वाला कार्बन है वो अल्फा कार्बन. सो अल्फा अमीनो कीटोन एज ए फाइनल प्रोडक्ट, राइट? सो हियर ketoxime tosylate, this is ketoxime tosylate converted to alpha amino ketone. So it is a Neber rearrangement. In mechanism part, let me take one simple example. For example, acetone is there, right, on react with the NH2OH, which is known as hydroxyl amine. So H2 from here, oxygen from here. So first of all removal of water molecule and it is converted to CH3 as it is. Now this carbonyl carbon attached with this nitrogen, right? So it is doubly bonded nitrogen and this nitrogen attached with the OH group, right? So this is the ketoxime. कीटोन में से फॉर्म हुआ है, that's why it is known as ketoxime. अगर aldehyde में से फॉर्म हुआ होता then it is known as aldoxime. Later this one react with the para-tolyl sulfonyl chloride, right? Now this is para-tolyl is like this, para-tolyl and here SO2Cl. para-tolyl, टोल्यून से याद रखना, para-tolyl sulfonyl chloride, right? So this is PTCl. What is the use of this reagent? This is act as a protecting group of oxygen. So first of all it protect the oxygen. So here OTS generated means ये जो टोसाइल पार्ट है वाला इतना पार्ट वो ऑक्सीजन के साथ कनेक्ट होगा. हाइड्रोजन फ्रॉम हियर, क्लोरीन फ्रॉम हियर. सो हियर रिमूवल ऑफ HCl, right? So this is your starting material, tosyl ketoxime, or we can say that ketoxime tosylate. Clear? Okay, now reaction with the base. For example, in generally Neber rearrangement, sodium ethoxide is used. So role of base is to abstract the proton. So out of this 2 methyl group, 1 proton is abstracted by this base. So here CH2, which is now negatively charged because abstract proton by the base, remaining part as it is. Okay, now this anion attack on the nitrogen. OTS leaving group leave from the molecule. OTS leaving group leave from the molecule, and now it is converted to 3-member ring. Here nitrogen as it is. Now this carbon is attached with this nitrogen. This carbon and this one is doubly bonded, and this carbon is attached with the methyl group. Right? So this is 3-member ring. 3-member ring having nitrogen as a heteroatom is known as azirine. Azirine. Okay. Now addition of water molecule. ये कहाँ से आया? यहाँ से. So now lone pair of oxygen attack on this carbon. Lone pair of oxygen attack on this carbon, and out of this 2 bond, 1 bond transfer to nitrogen. Right? So here nitrogen as it is, 1 bond transfer to nitrogen. That's why nitrogen is negatively charged. This carbon contain CH3, and now whole water molecule connect with this carbon. So here O, H and H. Now this oxygen carry 3 valency, that's why it's a positively charged. Now here positive charge, here negative charge. That's why 1 hydrogen transfer from oxygen to nitrogen. So here N is converted to NH, here OH, and here CH3. Right? Okay, now this lone pair of oxygen participate in the bonding. That means here nitrogen attract the bonding pair towards itself. Right? This lone pair of oxygen participate in the bonding. क्यों ऐसा कर रहा है? Because here 3-member ring. 3-member ring is not stable. That's why this is electron donating site, or we can say that driving force यहाँ से आ रहा. So this lone pair participate in the bonding. This bond transfer to nitrogen. Okay, A bond break हो रहा है. That means CH3, which is attached with this carbon, and this carbon attached with the doubly bonded OH. Again here oxygen 3 valency, that's why it's a positively charged. Right? This carbon attached with 1 more carbon, means CH2, and this CH2 attached with the NH part. Okay, nitrogen यहाँ से bond attract किया, that's why it's now negatively charged. Now यहाँ पे positive, यहाँ पे negative. That's why this hydrogen transfer from this oxygen to this nitrogen. So CH3, C double bond O. Right? 1 hydrogen transfer from oxygen to nitrogen. CH2, and this CH2 attached with the NH2. So alpha amino ketone is our final product. Clear? Alpha amino ketone is our final product. Okay, so in the first case, ketone undertake with the hydroxylam and hydrochloride to form its ketoxime, which is on reaction with the para-tolulyl sulfonyl chloride. Para-tolulyl sulfonyl chloride. So it's protect the oxygen and form base leaving group. Now role of base to proton abstract. So this negatively charged carbon anion attack on nitrogen. OTS leaving group leave from the molecule, and azirine form as an intermediate. Water molecule attack on this carbon. Nitrogen electron rich, electron negative. That's why it's attract the bonding electron pair toward itself. So here nitrogen is negatively charged, oxygen is positively charged. That's why this hydrogen transfer from oxygen to nitrogen. Again, lone pair of oxygen participate in the bonding. Nitrogen attract the bonding pair. Hydrogen transfer from oxygen to nitrogen, and the final product is alpha amino ketone. Right? So this is the complete mechanism of Neber rearrangement. Okay, now we are moving towards the application part. In application, Let me take one simple example. For example, if we are dealing with the acetophenone, so in simple thing, first one, it react with the NH2OH. So first oxime is converted and OH. Second thing, it react with the para-toluene sulfonyl chloride, so OTS group is generated, and the third one react with the base. Clear? So in this two step, this intermediate is formed by applying step 1 and step 2. It is give this type of molecule OTS. Now role of base to abstract the proton. So here negatively charged which attack on this nitrogen OTS leaving group, and then final product is here keto as it is, here CH2, and it is attached with the NH2. So in simple thing, अल्फा कार्बन का हाइड्रोजन रिप्लेस करके उसकी जगह पे NH2 ऐड करना है. अल्फा कार्बन का हाइड्रोजन रिप्लेस करके उसकी जगह पे NH2 ऐड करना है. Right? Let me take cyclohexanone. Again, the reaction condition is same. React with the NH2OH, then para-toluene sulfonyl chloride, and third one is NaOET, means base. So this is alpha carbon. This is also alpha carbon. So you can put NH group to any of this position. So here NH2. Clear? So alpha amino ketone is the final product. Let me take one more example. Suppose here is the keto group. So this is alpha, this is alpha. Right? So prefer position like this, not bridging position. React with the NH2OH, then react with the para-toluene sulfonyl chloride, and third one react with the base. Here keto as it is, and alpha position occupy the NH2 group. Clear? Okay. Suppose here is the benzaldehyde. So again react with the NH2OH, second react with the para-toluene sulfonyl chloride, and the third one react with the NaOET, and the final product is, so no final product, because aromatic aldehyde never gives Neber rearrangement. क्यों? क्योंकि ये बेस को जो अल्फा पोजीशन का प्रोटॉन एब्स्ट्रैक्ट करना है वो मिलेगा ही नहीं, क्योंकि इसका अल्फा कार्बन दिस वन एरोमेटिक कार्बन, सो इसके पास प्रोटॉन है ही नहीं. दैट्स व्हाई एरोमेटिक carboxycarbaldehyde, or you can say that aromatic aldehyde never gives Neber rearrangement. Thank you.